minus b plus or minus the square root of b squared minus 4ac all over 2a. You probably memorized that. Maybe you can still recite it. But can you say what any single piece of it means? Here is the claim of this video. That is not a formula. It is a set of directions for finding your way around one curve. And once you have seen the curve, you will not need to remember it. You will be able to rebuild it in about 10 seconds. Start with the simplest one. Y equals x squared. A valley, with its lowest point at the origin. Now here's what almost nobody gets told. Every quadratic you will ever meet is that exact curve. Not a curve like it. That one, stretched and moved. Watch. X squared minus 6x plus 5 looks like a different animal. But its graph is the same valley, slid 3 to the right and dropped 4 down. Lay one on the other and they match. So a quadratic is not really 3 numbers. It is one shape, plus instructions for where to put it. If it is one shape being moved, let us write it that way. Y equals a times x minus h squared plus k. 3 knobs. H slides it sideways. K lifts it up and down. And a stretches it, or tips it over into a hill. Now, h and k are the coordinates of the turning point, the vertex, and that is not a coincidence. A square is never negative, so the smallest that bracket can be is 0, and that happens when x equals h. There, y is exactly k. The vertical line through the vertex has a name. The axis of symmetry. Everything left in this video hangs off that one line. One problem. Nobody hands you h and k. They hand you a, b, and c. So let us convert once. Multiply out that bracket. You get a, x squared, minus 2ahx, plus ah squared plus k. Stack it against a x squared plus bx plus c. Same curve, so the matching pieces have to agree. The x squared terms already do. And the x terms tell us that b equals minus 2ah. Solve for h, and there it is. H equals minus b over 2a. That is the first half of the quadratic formula. And look what it is. Not a root. The middle. Let us do that with real numbers, on x squared minus 6x plus 5. A is 1, b is minus 6. So the axis sits at 6 over 2, 3. Now the height. This is the step with the famous name. Completing the square. Take the 6, have it to get 3, square that to get 9. Then x squared minus 6x becomes x minus 3, squared, minus 9. The bracket carries an extra 9 we never asked for, so we take it back off. Bring down the plus 5. Minus 9 and plus 5 leave minus 4. So the equation is x minus 3, squared, minus 4. Same curve. But now it tells us where it is. Vertex at 3, minus 4. And now watch how little is left to do. We want the curve to hit 0. Move the 4 across, and x minus 3, squared, equals 4. Then comes the only step in this whole video that is not bookkeeping. Take the square root of both sides. X minus 3 is plus or minus 2. Plus or minus. That is the symmetry, written as algebra. The curve is a mirror image about the line x equals 3, so its two crossings sit the same distance out, one each side. 3 plus 2 is 5. 3 minus 2 is 1. 2 roots. 1 and 5. And we never wrote down a formula. Now do exactly that, but with letters, and the famous formula falls out. Move k across, divide by a, square root both sides. X equals h, plus or minus the square root of minus k over a. That is it. Everything after this is substitution. We know h, minus b, over 2a, and k, completing the square in general, is c, minus b squared over 4a. Put those in, tidy the fractions, and out drops the thing you memorized. But now you can read it. Minus b over 2a is the axis. The root part, over 2a, is the distance out to each crossing. Middle, plus or minus. Half the width. It was never anything else. So here is one to try, and I want you to beat the formula with it. X squared minus 10x plus 21. The middle first. 10 over 2, 5. Then the half width. B squared is 100. 4a, c is 84. 100 take 84 is 16. Root 16 is 4 over 2a, which is 2. Half width, 2. Pause here if you want to finish it yourself. 5 plus or minus 2. 3 and 7. Check it in your head. 3 sevens are 21, and 3 and 7 make 10. No formula recalled. A middle, and a distance either side. Back to the original coefficients now. The a is the same in both forms. It stretches the curve, or tips it over, exactly as before. So watch what the other two do. Start with c. Change the 5 in our equation, and the shape does not change. The axis does not move. The whole curve just rides up and down. Which makes sense. Put x equals 0 in, and the other two terms vanish, so c is the height where the curve crosses the vertical axis. Add 1 to it, and every point, vertex included, goes up by 1. So c is a lift. Hold on to that. In 2 minutes it explains the discriminant. B is stranger. Changing B cannot tilt the curve, because these parabolas do not tilt. It slides the vertex. But along what? The vertex sits at minus b over 2a, at a height of c minus b squared over 4a. Call that x value h, and the height becomes c minus ah squared. But look at what that is. A constant minus a times something squared. That is a parabola. So as b sweeps, the vertex traces out a second parabola. Same stretch, upside down, through c. Ours rides along y equals 5 minus x squared. Our own curve, flipped. The shape is chasing itself. Which brings us to the part everybody is made to memorize. B squared minus 4ac. The discriminant. The vertex height is c minus b squared over 4a. Multiply it by minus 4a, and watch. First term, minus 4a, c. Second term, plus b, squared. That is the discriminant, exactly. So it was never a separate idea. It is the height of the vertex, scaled, asking one question. Where is the vertex? Our valley opens upwards. Vertex below the axis, and the curve must climb back through it on both sides. 2 roots. Vertex exactly on the axis, and it grazes. 1 root. Vertex above, and the curve only ever goes up. It never reaches it. Now the case everybody is told is the end of the road. Lift our parabola until the vertex clears the axis. X squared minus 6x plus 13. Same shape, same middle at 3, but the vertex is now 4 above instead of 4 below. The curve never crosses. The discriminant is minus 16. No roots, and most textbooks stop there. But read what our formula says. X equals 3, plus or minus the square root of minus 4. It has not failed. It has handed us the square root of a negative, which is 2i. So the answers are 3 plus 2i, and 3 minus 2i. The roots did not disappear. Still a middle plus or minus a distance, still symmetric about 3. The distance just turned 90 degrees, and points off the number line instead of along it. So, what is worth keeping? There is one parabola. A stretches it, H slides it, K lifts it. Every root is a middle plus or minus a distance. The middle is minus b over 2a, always. And the discriminant was never a rule to learn. It is the height of the vertex, scaled, asking whether the curve reaches the axis at all. One shape. One line down the middle. Everything else is where you put it. If that was useful, subscribe, and I will see you in the next one.